Okay, there's another video on introduction to hypothesis tests for population mean using p-value method. That might be a good one to watch first, but I'm going to go ahead and go through this a little bit more quickly. So here we have a prior report, so this kind of claimed population proportion of 81%. And then we also have a sample where 118 out of 150 say that they'd recommend the brand. So we're testing whether or not the sample bears out this report that was done last year. So what do we start with our null hypothesis? Null hypothesis always, whether it's mean or proportion, always starts with this equal sign. And in this case, since we're testing the population proportion, that's this. This is the sample. P hat is the sample. We're doing the, oops, there we go. Population proportion. What is it equal to? We're testing whether it's equal to that claimed 0.81. Well, 0.81. The alternative will also always have the same parameter, same number. We just need to choose which symbol goes here. So, the suspecting is that it might be actually lower. So here, less than 81%. That's what we're testing. We're trying to see if the real population proportion now is less than what it was earlier on. So that less than, we're going to keep same parameter, keep same number as always. We're going to use a z-test, which is what we do when we're working with proportions. And in order to use it, there's some rule of thumbs. N times p, well, this is the number of people in our sample, 150, and p is our 0.81. So 0.81 times that 150 gives us 121.5. And here n times 1 minus p, so 1 minus p would be 0.19. So we'd have 0.19 times that sample size of 150 is 28.5. And the general rule of thumb is we'd like both of these numbers to be over 10, at least 10, and we certainly are here. What would you do if it's not over 10? I don't think they would put a question in here like that, because then you couldn't really conduct the test unless the whole entire question focused on whether or not NP or N minus 1P were greater than or equal to 10. Maybe they could ask a question like that, but in general, in the flow of a larger question, they're not going to throw. In reality, if you got that, that'd be a little tricky. You'd probably want to either increase your sample size or carry out the test and then just mention it as a limitation. So are we doing one tail or two tail? Remember, we said less than. That's a one-tailed direction. We're only going to be able to reject the null down here somewhere. Our test statistic is based on this formula right here. So our sample proportion was, did we ever calculate that? Maybe we didn't. 118. Let's do that before we, oops. So this is 0.787. That's our sample proportion. So we're taking that number minus our null hypothesis proportion, which is 0.81. And then if we go back to that formula, we're dividing by, and we can do the square root before or after, I think. So we're dividing by the p, which is that 0.81. 0.81 times 1 minus p, 0.19, divided by, and our sample size here was 150. It's a pretty big calculation there. Test statistic to 3 decimal points is 0.728. Okay, so you can see where we are. And where's the p-value? Well, p-value, we might have to shade one tail or two tail. It depends what kind of test we're doing. Since we are doing a one tail test, we only shade the left tail. If we had been doing a two tail test, if we just wanted to see if the proportion is different than that 81%, not necessarily lower, then this would have been a two-tailed, and then we would have shaded both sides of our test statistic, the absolute value of our test statistic. Okay, what is our p-value? Well, it's this shaded region here. So the question is, what is that shaded region? And if we go to our calculator, we have this probability that z is less than or equal to. So we can put in our negative 0.728 there. Do we need to subtract this from 1? We don't, because the calculator gives us to the left, and that's exactly what we want to find. We want to find that shaded area, which is on the left side, so we don't need to subtract this answer from 1. If we had gotten this area over here somehow, then we would need to subtract from 1. Okay, and so how does that bode for us? Well, we wanted a 0.10 level of significance. That's our limbo bar. We're trying to get under that to get a statistically significant result, to reject the null. Did we do that? No, we did not. So our p-value was 0.233, which is not below 0.10. So since we were greater than the level of significance, we failed to reject. P-value low, the null must go, but our p-value wasn't low, so there's not enough evidence to conclude that less than 81% of all dentists now recommend Grand.